Welcome, everybody, to this presentation. We are going to talk a little bit about the work we have been doing inside Linaro to enable confidential computing support on ARM platforms. I am Leonardo Garcia, the chair of the Linaro Data Center Group, and Thomas, Mathieu, and Kevin are the real engineers doing the work. So we have collaboration, of course, of many others, right, like Jean-Philippe and others that are not able to be here. But yeah, this is the main team inside Linaro. Okay, so confidential computing. In case you never heard about confidential computing, it's basically, a technique to protect data in use, right? Everybody's quite familiar with, encryption to, hide information in data at rest or in data in transit through the network, for instance, right? But the thing is that for data in use, there weren't many techniques to avoid other process or even the host of the machine to access the data that was being run by a virtual machine, for instance, right? We had on ARM the Trusted Secure Zone, right, which has been implemented, I think, 20 years ago, which is exactly the same concept, right? But what happens is that in the latest years, there has been a desire from the market to be able to also run regular Linux or regular operating systems in enclaves or in trusted execution environments, as we call it. So that's exactly what is happening, in the market right now in the industry. All the main architectures that are available out there, they are implementing support for some kind of confidential computing, and that's exactly what we're doing on the ARM ecosystem with the confidential compute architecture, right, CCA. So the interesting thing about CCA is that it's not just a hardware specification. So the hardware specification is the RME, the Realm Management Extension. Realm is the name that we that ARM gave to the trusted execution environment in this implementation. But CCA is really about the whole software stack, right? Not only the hardware implementation. And what we are doing at Linaro together with our members is we are trying to implement some kind of reference implementation, not in the sense that this will be the default standard adopted by everyone, but just that we can provide to the community a set of software that cover all the software stack here, and that can help you to implement and deploy confidential computing in your environment. So, of course, that ARM is driving this effort in terms of enabling new features, in the Linux kernel and in the firmware, right? But then, from our perspective at Linaro, this work has been started inside the data center group. So we have members, and the members are willing to accelerate the adoption of confidential computing. And they, asked us to help with that. So in which areas Linaro is helping in this work, right? As I said before, we are trying to work on all the software stack. From our point of view and the point of view of our members, QEMU is a very important portion of the software stack because they use QEMU as an emulation environment. And QEMU is also used as a virtual machine monitor to launch virtual machines in general, right? So we have been working to enable the RME support in the QEMU emulation environment. We have also been working to enable QEMU as a virtual machine monitor so that you can not only, create virtual machines on ARM platforms, but also create confidential virtual machines, right, which are basically realms. We have been helping with the firmware stack as well, so TFA, TFRMM, EDK2, and we want to provide components that can, start a realm as easy as it is today to start a confidential, a regular VM, right? So with that in mind, we separated the work in two pieces. So the first one was to attack the low-level part of the stack. The second one was to attack the high-level part of the stack. It's interesting to notice that every time I show this picture, someone comes to me saying, this picture is a little bit complex. And I say, yeah, it is, because, that's unfortunately or fortunately, I don't know the environment in which we live in, right? So if you look at the ARM platform today, you can have, of course, real hardware. I might have a pointer somewhere. Well, anyway. Oh, here it is. We have real hardware. We have the FEP models provided by ARM and that are used by many of their partners. And we have the QEMU emulated environment. For quite some time now, Linaro has been investing to provide an SBSA compliant machine type for QEMU. This work is also being done inside the data center group, which means that if you use this QEMU machine type, in theory, it's SBSA compliant. You can test software on this machine type, and when you move your software stack to a real hardware that is also system-ready compliant, everything should just work, right? So we provide this for quite some time, and we are providing support in the RME in this piece as well. We have, of course, the TFA. We have the secure side, the secure zone, right? With half new OPT that is also a project provided by Linaro. When I joined Linaro, I thought this was not very used on the server side, but it is. I mean, there are many server platforms that are using secure zones. And then you have the normal world, right, with Linux running as host, QEMU and confidential VMs, or regular VMs and containers, all the stuff that everybody, uses. And we have the new Realm environment, which allows you, through the use of Realms Management Monitor, right, to launch Realms. So on the low-level software stack, as I mentioned, we are working on all these things. I have links here for the code that we have been developing. Since QEMU 8.1 mid last year, we have support for RME extensions in QEMU, so we can emulate an environment with capability to spawn realms. We have expanded these, we are expanding these to support on the SBSA machine type as well. We have patches for TFA, TFRMM, and DDK2 available in CodeLinaro, so you can just download and try yourself. ARM provides patches for the Linux kernel and KVM2 as well, so the branches are linked here. The solution is currently only running on QEMU Virt machine type, which is a machine type that we use to enable new features inside QEMU for ARM platforms. But as I said, we are working to port these features to the SBSA reference machine type as well, because that's what we usually want to use on servers as a reference platform. We are integrating our software stack on TRS, which is the Trusted Reference Stack developed by Linaro. This is basically an internal project in which we include the features that we developed to make it easier to run CI with these features. And we have a documentation available. The link is also on the presentation, where you have instructions on how to build all this environment and run tests on your machine, right? We have quite a few members that tried it successfully. So I'm pretty sure that if you are interested, you will be able to run as well. I tried and I was able, so anyone should be. On the other side, as I said, we are working on the high-level software stack, right? Today, when you talk about servers and how people is deploying or are deploying workloads on servers, this basically means containers, right? When we looked at the ecosystem, we decided to work on confidential containers, which is basically a project built on top of Kubernetes on the CNCF. And we decided, these confidential containers, they don't have support for CCA yet. So we decided that we should work with the community to enhance confidential containers and provide support for CCA there. The other architectures, if you look at Intel TDX or AMD SEV, SNP, they are working with CoCo as well to enable their support, right? CoCo uses Kata containers to launch containers inside virtual environment, right? And in this case, what we are targeting is to create containers inside a confidential VM, right? To make sure that they are completely isolated from the rest of the world, specifically isolated from the host as well. Another important aspect that I didn't mention so far, but it's extremely important in confidential computing, is the right side here, the attestation agent and the attestation service, the key broker service. So what that means, I mean, when you are running a confidential workload, you not only want to make sure that the workload is isolated from the host and from the rest of the data that is executing in the machine. You also want to make sure that the workload you are running is exactly what you expect it to be run, that it hasn't been tampered by an attacker, that it hasn't been changed in some way, right? And in order to make sure that that's the case, there are mechanisms that you can use to verify the authenticity of the software that you are running, right? This is an important aspect of CoCo, and we are definitely, very interested to make sure that this works on with CCA, because this is definitely an integral part of what the confidential computing solution is. So, in order to enable these things, we have been working on Kata containers, of course, because otherwise it's not possible to launch confidential VMs on ARM platforms. Kata containers today has support for other architectures, confidential virtual machines infrastructure. It didn't have support for CCA, so we have been implementing this. There is a code repository as well available in the presentation. We are not complete. This is work in progress yet, so there is a number of features that we support. But we are working to make sure that we support the other features needed here. So Kata containers, they have a V3 now, so we are working to make sure that this is supported. We only support the QEMU backend because that's where we started our journey in terms of emulation and virtual machine monitor. We will work on cloud hypervisor as well pretty soon. We still don't support boot with firmware, EDK2 firmware on Kata containers, but that's just a question of time. So we are working on these as we speak. At the same time, we have work on confidential containers as well. This version of the presentation is a little bit out of date, so there is a link in the version that you're going to get. We have implemented some changes in trustee as well in order to support CCA. And we are, as I mentioned before, working to make sure that the attestation and verification steps are available in the software stack as well for CoCo. And how does that look like, right? So if you look at CoCo today, it has, of course, the infrastructure to run, the containers, the pods inside the virtual machine, a confidential virtual machine in this case, and it has big infrastructure to provide attestation verification services. It has a key broker service and an attestation service. There isn't, right, any support on the attestation service for CCA yet. So we have been working to provide this. And the way we are doing this is that we are leveraging Verizon. Okay, Verizon. I always speak this name incorrectly, so Verizon. So we are leveraging Verizon, which is basically a confidential computing consortium project that was created by ARM some time ago, and whose objective is exactly to be able to provide this kind of attestation services on CCA platforms. The caveat with Verizon is that it runs remotely, right, as a service, and the confidential CoCo has support for attestation locally as well as a local service. We created Run CCA token crate that basically extends Verizon as a library, and we can just link this to CoCo and provide local verification on CoCo, right? And we are working as well to extend the attestation service in CoCo to talk directly to Verizon. So I mentioned the CCA token crate, right? So this is basically provide a command line tool in the library as well to decode and verify CCA attestation tokens. The code is published, it's public, so anyone can go and try the tool yourselves. We also created another tool whose name is Realm Token Crate, actually. And it calculates the realm initial and extended measurements. So this is important because when you are running the environment, you have to have a measurement against which you are going to compare to make sure that your environment is exactly what we expected. So these tools are helping us in this process. The idea is that at some point in time, that is not too far away, we can have some kind of general services that can get input values, we call them endorsements, right, from the supply chain. So basically, hardware providers, firmware providers, software providers, they provide reference values or basically hashes of their platforms or softwares. The verifier collect all these values, so that anyone that is trying to run a software in a platform can just ask the platform the reference values that they have and send them to the verifier so that the verifier can match and see if they are the correct ones or not, right? And this will be all done through some kind of policy because, of course, the versions that you trust change along the time. So maybe a CVE is discovered or something like that that will block you from running certain software. So that's the kind of infrastructure that we are envisioning for the future. And now I will invite Thomas, because I'm really not the expert on this, so that he can talk about the latest things that we have been doing. We have like a proof of concept, right? That and put together lots of these pieces. So Thomas.
Yeah, thank you, Leo. So this thing is is a small tool, is a CLI thing that we are putting together and prepackaging with the confidential guest image, so that when you instantiate around you can use it on a command line. And the idea is that we want to use this tool to basically showcase a few representative. A few interesting things that you can do when you have attestation in your toolbox. So stepping back 10 seconds just to give you a bit of context. So attestation is this sort of strong and fine-grained authentication primitive. So whenever you have a protocol flow that depends on some kind of authentication step, then you potentially have a hook point to actually add attestation into your flow to enhance the security posture of the authenticating principle. So, for example, every time you need to establish a secure channel, every time you need to, say, for example, you have credential issuance through a CA or other kind of identity providers, or if you have to access resources, then these are all potential use cases where attestation can be put on top of either the existing authentication credentials or as a replacement of these. So we are looking at this space and trying to identify some interesting things to explore, or to showcase what a realm can actually do for the user. And so there's this tool, this one-stop shop with multiple subcommands where we want to explore the various things. And for now, we just started a couple of weeks ago, 3 weeks ago. So we only have two things. One is basically a smoke test that allows you to verify that the plumbing in terms of the ability of the user land to access the token through the TSM report ABI is in place, so that you can basically get the token from the RMM a real token and present what it contains in a human readable fashion, because it's a seaboard blob, so it's binary and it's a bit non-legible otherwise. And the second thing that we've implemented is a bit more interesting, is a full remote attestation session that the Realm, basically the Realm engages in a remote verification session with a Verizon service endpoint, which is a bit more complex in the sense that you need to open the verification session with the remote thing, get a nonce, send a nonce to the RMM, get the token back, submit the token, obtain, and then let the verifier decide whether the TCB that you presented through the evidence is the one that is expected, and the actual realm is the one that is supposed to be running in that case. So we have plans to add more of these sub-commands, an attested TLS session, an attested CSR session when you can get an X509 certificate. We might want to look at OAuth flows as well, to provide the widest possible set of use cases. I think one interesting point here. Did I say everything I want? No. Okay. So we have paired this with a public instance of Verizon service. So we have deployed in Linaro infrastructure at verizon.test.linaro.org. Port 8080 exposes the verification interface. So it's a complete Verizon cluster, although there's no user interface. It's a bit brutal in that sense, but it does the job, and we think we want to evolve that in the future to add more bells and whistles.
You can try.
Yeah, it's publicly available.
Just don't drop the server. Don't attack it.
So we are very conscious that there's a lot of information here to digest, simply because the technology is extremely complex. There's a lot of pieces that need to fit together. And in order to highlight that and to make it easier for people to get into the field and to understand what's been done, there's a link to the documentation in the slides. The documentation takes you from 0 to hero in about an hour. So you can have a way to compile everything that is on here. There's no black box. Everything is in the clear. You can reproduce everything that is there on your own machine. And then, like Thomas and Leonardo have explained, we also have an attestation services, a proof of concept that you can run either on your own machine or in the clouds, that allows you to go through a complete scenario that would be spinning off a realm. That realm gets the token from the hardware, goes off to, or produces a claim, goes off to a verifier, and then comes back. And then after that, you have a proper, you are certified that you have a system that can work properly. So there's no black box, as I said, everything's in the clear. So if you are interested, go have a look at it.
Ask questions.
Yeah, the questions.
Ask questions. We are welcome to answer any questions. I just go through the last slide here. I mean, there is a list of feature steps, things that we are looking at right now. So CCA has an upcoming support for memory encryption, so we will be working on that. There will be, at some point in time, of course, device assignment support, and we are working or planning to work on SMMU support in QEMU to support this device assignment in the future, Cloud Hypervisor, as I mentioned. And we definitely want, at some point in time in the future, to have an end-to-end demo with CoCo, deploying and verifying the workloads using Kata containers, hopefully with a lightweight firmware. That's our final goal, let's say.
We are fully open to suggestions. So if you try this and you find something that's not working, or if you have suggestions on something that you'd like to see improved, by all means, reach out to us, and we'll be happy to have this conversation.
Questions?
Hi. On the status of the patches that you were showing in the previous slide, firmware and kernel. So I get it that on the kernel side, you're picking up public patches available, hosted by ARM on some development branches. How about the firmware pieces? And is there any chance to move those to some, trusted firmware development branches, or to move the conversation on the trusted firmware mailing lists, for example?
Well, I think we are, the goal is, of course, to get all the patches upstream. It's just that we didn't have time to do that yet, so we are hosting everything in Code Linaro right now. I think we have discussions ongoing, right, on trusted firmware. Matthew is probably the best person to answer that.
Yes, and the problem is that all of these pieces have to move in sync, so we were waiting for the second revision of the kernel patches to come out. That came out, I think, a month, 6 weeks ago. So yeah, that was a blocker for other patches or for other discussions on these patches that are hosted out of tree to take place. So it's a lot of patch to move in sync, and those conversations are happening. And the thing we want to do is it's not we, right? It's the authors of those patches. So we certainly we're not going to step in and say, hey, we're going to take ownership of that, so step aside. That's not the goal. So whoever wrote those patches, I think it's an ARM. Jean-Philippe has also wrote some of them. It's a matter of looking at where we are and getting these people or working with them to upstream and do that in a way that the rest of the solution works. But there's no intention of keeping anything out of tree.
Any other questions? Oh, okay.
No, perfect. Absolutely. We are well aware that there are so many moving parts and 5 or 6 repos to keep in sync. So you probably need a stable point to do your testing. Clearly, it's understood.
Right.
So,
not only that, right? We want others to try. So the documentation is pointing to our repo because we know our repo is working, right? And other repos might be in different stages with different set of patches, and
Yeah, understood. Thanks.
And we have the outline of a CI that's coming in, right? So we have the outline of a continuous integration cycle to come in. And so the first step is to have builds. Second step is to start monitoring patches for the kernel rebased on the latest, and then just incrementally, as we see things moving forward, just adding more pieces of the puzzle so that we have a holistic CI for all of the pieces of the solution.
any other questions?
Yeah. Hi. You mentioned two command line tools which can compute the initial measurement and the extended measurement of the RAM workload to produce the reference values to compare against in the attestation service. How payload is populated into the RAM, it can be varies among different VMMs. Are your tool specific to the QEMU VMM? And does it produce always a consistent result? I mean, the pages is always delegated in the same order to make sure that the running hash is consistent across the runs?
Yes, Tamas, this is Jean-Philippe work, and it's a fantastic thing that basically it specifies a protocol, and then the KVM or QEMU just adhere to the protocol and do the things in the order expected. So. And the measurements become consistent across different VMMs. So,
okay. So any VMM can implement that protocol and interface and show that the values are consistent.
Exactly.
Okay.
And that's specified in the doc repo of the tool. Yeah. So if you go to realm token/doc, there's the protocol. For now, it has QEMU and KVM entries, but further will be added in the future, hopefully.
Okay, thank you. And what is about the extended measurements? In that order, you need to know in which order the components are loaded and how the extend command is executed. Can it be known at container build time?
Not sure about this. We need to ask. Jean-Philippe.
Okay, thanks.
I will do that for you.
Okay, folks, we don't have time for any more questions. I invite everybody that is really interested in CCA to stay in the room, because Dan Handley will give the next talk here, right, about the ARM, what ARM is doing in this enablement as well. Thank you very much. If you have any other questions, just catch up with us.